Hey guys, welcome back. So in this video, let's discuss a few important topics of Java. So we're going to discuss about exceptions, generics, and collections. So now let's see what exceptions are. So exceptions are the kind of scenarios in our program which might lead that program to terminate because of some input or because of some sort of event. So if our program is going to shut down because of an event, so it is actually called as an error because an error we cannot handle it. But if you know that whatever the error, so which is causing this abrupt termination of the program, if it can be handled by us, so we can call it as an exception. An exception is actually such an error object which can be managed through program if it is known to us earlier, right? So how can we expect the errors that we might get? So exception is actually in program, since we define rules, so we know when the rules can be broken, and we know if the rules were broken, if there is a mechanism through which we can make sure that even if the rules are broken, we can execute the rest of the program uh, uh, smoothly without abruptly ending the program. So what is the mechanism which is going to allow us to kind of check for such errors and remove not exactly remove the statement, but kind of manage all the statements and let the rest of the program work successfully. So such sort of uh, a feature is the exception handling. Exception handling is the one feature that makes Java a robust language, since it can manage exceptions at runtime and at compile time. So it is going to make sure that the program will run in most of the cases, with respect to any sort of scenario, right? So to understand exception, let's see how it is defined in Java. In Java, so we have the object. An object class is at the topmost hierarchy, and then from the object class, a class called throwable is inheriting. A throwable, it defines any object which can be thrown by the program. So what can be thrown by a program? A program might throw errors, or it might throw exceptions. So if it is a throwing error, so can we do anything about it? We actually cannot do anything about it. So since it is an error, it is indicating that something is wrong with the program. So we wish not to proceed with the program. But there is another class called exception. An exception is a special case which occurs only on special events. So it is sort of an exceptional case. So when it occurs, so it is sort of understood that we may be able to handle the exception, right? So this is the exception object, and the exception object can be further divided into a runtime exception and compile time exception. And there is something called as checked and unchecked. So checked exception is that even during the compile time, so we'll be able to identify if a method might throw an exception. So by examining the a signature of the method, we can understand that if it throws an exception. So if it indeed throws any exception, then we have to handle it at the so it will be checked at the compile time only. So those are the checked exceptions, and any exception which is not explicitly thrown by the method. So all those are the unchecked exceptions or the runtime exceptions. So since only at the runtime we might be expecting an exception. Right? So what the system does when an exception occurs. So when an exception occurs, so all the information about the exception, like where it occurred and from which method, and all the information about the exception, it will be encapsulated into an object, and it will be returned to the function where the exception has happened. Then that function is supposed to handle that exception. How it handles? So we have an exception handling mechanism. So this is what I have explained. So in the main method we got an exception, and that exception, so using the exception all the information will be captured, and the information will be present with the Java runtime, and the runtime is going to identify which method has from which method we got all these exception objects. So it is going to return the exception object, and if there is any exception handling mechanism, it is going to handle the exception, right? So this is how we handle the exception. So we are going to place the code which might throw an exception in this try block, and then we use the catch block. So the catch block is used to catch the exception, so the exception object that we have defined earlier is going to be caught here. So that exception object, so using the exception object we can get the details about the exception and we can handle it here. And then this is called as the finally block. So the finally block is used to is actually used for some sort of sensitive code which has to execute in any case. So we're going to place all those critical sections of code in this final block. So without exception, so whatever the uh, so the code that we have in the try block, so it is going to be executed, and when the last statement is executed without any exception, it is going it it will directly go to the final, directly go to the final block, ignoring the catch block. Since the catch block is only supposed to execute when an exception occurs, and then it will move to the next line. But when we have an exception, so the a statement where the exception was found, from that the entire control will be given to the catch block, and the code segment of this catch block will be executed, and the finally, so the final block will be executed at any case, and then it will move to the next line. So in this case, we can run, we can run the program even when the exception is, even with the exceptions. So in this way we can handle some sort of errors even when they occur. So now let's discuss about the generics. So generics are needed when we are trying to create a class, which so in a class, if we were to create objects of some certain a hierarchical class, then there is actually no way that we can accept any hierarchy, or have the ability to know which class that we are supposed to create an object of. So in such a, so in such a such a situation, usually we use the object class. So since it is the a superclass of all the classes, any class can hold the an object instance of the object class, right? So it is actually one way that we can do that. But if you are very specific in our class, and we want our class to only accept a single object at a time, but it should have a flexibility that we can create a multiple instances of this a same class with a different a class members. So for that we may use something called as the generics. So in this example you can see that there is an integer which is extending the number, and now I wanted to create a class called as box, and I want this box class to accept both numbers as well as integers. So is there a way that I can enforce a rule such that this class will get the ability to accept integers and numbers? So if we were to make this class accept anything, then we could have had this as an object and of the class object. But here we are trying to only accept the ones which are having this relationship, that they are inherited. So if we were to do such sort of thing, then since we cannot use the object, right? So since so using an object class, it can be resolved, but if it has some sort of inheritance, if it has some sort of method functionalities which have to be handled, then there is no there is actually no way that we can enforce that, but it can be enforced using the generics. And the last topic is about the collections. So we have arrays, right? So by using arrays, we can only store objects of a single class, and arrays are not dynamic, so they have to be statically mentioned. So we have to statically define the size and decide on the a type of object. But using the collections framework, we can sort of have a lot of uh, templates and a lot of classes to work with different data structures. So the collection framework is sort of divided into two. So we have the map. So the map is sort of different from the collection. A collection is predominantly handled by a list, a queue, and set. So whatever we mentioned in what are the things which are mentioned in blue? These are the classes which are implementing the interfaces which are above them, and we have the priority queue and array queue. So all these things are the classes of these interfaces. So these interfaces they actually provide you some sort of methods which are supposed to be implemented. So why are we supposed to use interfaces? So by using interfaces, we are making sure that every class in this collections framework will have the same rules applicable to them. So if one of the class is using a, a method called add to add elements into it, then the same add method has to be overridden or implemented by the other implementing classes as well. So this makes sure that all these methods are consistent throughout. So now let's see why we have a lot of them and how are they different. So in this list we have array list. Array list is very much same as the arrays, but it can have a variable size. And then we have the linked list. As so it internally uses the a doubly linked list, so it can iterate in both the directions. And then we have a vector and array list. So they both are kind of same, but a vector is asynchronized and it is a legacy class. And then we have stack is just implementing the data structure stack. It has the methods push and pop with it. And then when it comes to queue, so we have something called as a priority queue. A priority queue is also it internally uses the red black trees to store them. So it will be internally sorted based on the priority. And then we have the array DQ. So array DQ, so the DQ is the a double-ended queue. So it offers you a similar functionality as a doubly linked list by following the last in last out principle. And then we have set, hash set, and so okay, the hash set, uh, i- the hash set is an ordered collection of elements, and all the elements are going to be unique. And the linked hash set is also, so the linked hash set will also not allow any duplicates, but the linked hash set, so when we try to retrieve the values, so the values are going to be retrieved in the same order in which we have inserted. And then we have the tree set. The tree set, so it is going to internally sort the elements. It is also going to use the red black trees internally for that matter. And now coming back to maps. So in maps you have the sorted map, so in map we have the sorted map called as the tree map. So this is very much the way how it so how the tree set works. So they both also use the red black trees internally to sort the data at the time of insertion. And then we have the hash tables and linked hash maps and the normal hash map. So they use the a technique of hashing, and there is no a specific order for them, but the mapping will be but the mapping will stay consistent. So this is about the collections, and so that's all for the video.